Very warm welcome. Good afternoon, everyone, and welcome to today's webinar. My name is James Thomas. I'm the founder and managing director of Digital Education Partnerships Indonesia, DEPI for short. Whilst we are based here in Indonesia, we do partner with international edtech companies and schools across the entire Asia-Pacific region to explore practical digital solutions that can help enhance school operations, improve teaching and learning, and strengthen student outcomes. So this session today is part of our DEPI webinar series, short, free, and practical sessions designed to introduce innovative education platforms tailored to the needs of international schools. So I'm delighted today to have a third session actually with SolverEDGE, which is a machine learning driven platform developed with research backed by the University of Melbourne. Backed by this research and pilot programs across the Asia Pacific, SolverEDGE equips students grades 3 to 9 with the essential critical thinking and problem solving skills that AI cannot replace. So SolverEDGE is about developing the 6 human-centric competencies critical for success in the new AI age that we are entering. So these are perseverance, reasoning, inferential reading, general knowledge, speed and accuracy, and method and strategy. And what makes SolverEDGE unique is how its adaptive diagnostics and guided training help schools move from diagnosis to growth and cultivate thinkers in your classrooms. So we've had a lot of interest in today's topic with schools in attendance from China, Singapore, South Korea, Japan, Thailand, and Malaysia. So again, a warm welcome to you all and thank you for your time today. So today's session is scheduled for approximately 45 minutes, and we'll be focusing on how to integrate and cultivate deep thinking skills, covering pedagogical strategies, practical ways to incorporate human-centric skill development into daily teaching. AI is a partner, not a threat, exploring technologies that enhance, not replace, an educator's teaching potential, and integrating thinking skills. So how to embed these critical competencies into other subject topics, after which we'll have a quick guided demo of the author platform and take a look at the tools teachers are using to manage and tailor the learning experience of their students. So I'm delighted to introduce our guest speaker today, Geoffrey Ho, based out of Hong Kong, who serves as the Chief Operating Officer for SolverEDGE. Geoffrey has extensive experience in educational technology and operational strategy, focusing on scaling up research-backed programs to deliver real impact in schools. So Geoffrey is going to walk us through the research-backed methodology. He's also going to share some practical pedagogical strategies and demonstrate how teachers can effectively use the SolverEDGE platform to drive student growth. So bit of housekeeping before we get started. Please keep your microphones muted unless invited to speak. You're welcome to post any questions in the chat during the session, and we'll endeavor to address those as soon as possible. We'll also dedicate 5 to 10 minutes at the end of today's session, where Geoffrey will address as many of your questions as possible. So the session is being recorded, and we'll be happy to share the recording and the slides with all those in attendance after today's session. So thank you again for joining today. Fantastic to see so many school leaders and educators from all across the Asia Pacific interested in moving their students from simple diagnosis to measurable, sustainable growth. So without further ado, I'd like to hand over to Geoffrey Ho. Over to you, Jeff.
Thanks a lot for that introduction, James. I'm just going to quickly share some slides with everyone. All right, hope everyone can see that. So warm welcome to everyone to our third webinar, from diagnosis to growth. Cultivating thinkers in your classrooms. So yeah, I'm Jeff, the COO of SolverEDGE. And a quick intro to those that have not joined the 2 previous webinars. We're an Australian and Hong Kong-based team of educators and developers, and we've spent the last 18 months turning the latest cognitive science research on problem solving into a practical author and diagnostics platform. Some general background about our company. We are the EdTech arm of North Shore Coaching College, which is an Australian company with over 30 years of experience and 65 campuses. So we've been running our platform live with 2 schools in Hong Kong and also some of our students in Australia and this semester. And now what we want to do is understand which international schools in APAC also see the same urgent need that we do. And so over the past 2 months, we've talked about why this shift in education is urgent. We've talked about how AI is automating routine tasks and making uniquely human skills like problem solving and thinking skills critical to future success. We introduced our research-backed framework, the 6 pillars of problem solving, and we showed you how our platform uses computerized adaptive testing to diagnose a student's unique cognitive starting point. But a diagnosis is only the beginning. The real question, and the question I'm sure you're all wondering, is what comes next? How do we, as educators, take that diagnostic data and use it to foster genuine growth? And that's exactly what we'll be covering today. This session is the practical follow-up with some concepts and ideas for you. We'll move from the why to the how, and we'll explore pedagogical strategies to build these thinkers, show you how to integrate thinking skills into your daily curriculums. We're going to be reframing AI as your collaborative partner, not as a threat. And I'll also be giving you a live demo of our author platform where all of these concepts come together. So quick recap. Yep, so we've got the 6 pillars of a strong problem solver here in the diagram in the right-hand corner. So that's literal and inferential reading, topic knowledge, method and strategy, general knowledge and sensorizability, speed and accuracy, and perseverance. So let's talk about the teaching strategies and how to build these traits in students. First, we have literal reading. And this is the skill of grasping what is explicitly stated. This is essential for accuracy. Simple, powerful techniques to train this could include asking students guided write their questions. So these are questions that ask for what is directly stated in the text. It requires them to find and connect information and train students to hunt for facts. Examples of this include, example questions would be, what is the first step in this process? Or what date did the event occur? Another useful technique you can use is structured annotation. Teach students to highlight or underline key details and definitions that are directly in the text. This will build the crucial habit of attending to evidence. Then, once the literal reading foundation is solid, we can layer on inferential reading. And this is the skill of reading between the lines. This is where critical thinking kicks in. So to do this, we can ask inferential questions that go beyond the literal words. These questions require students to make logical conclusions based on evidence in the text. And what they do is help students to build the ability to connect clues, understand emotions, and predict what's not directly stated. Some example questions of this, why did the character do that? What might happen next in the text? How do you know the setting is dangerous? Also, another way to train inferential reading is by making it visible. So when you're analyzing text with students, what you can do is teach students to use charts. They can list out clues from the text on one side of the chart, and then their inferences on the other side. This will make the hidden reasoning visible and debatable. So by scaffolding from literal to inferential, we're not just teaching students to read words, we are teaching them to uncover meaning. And that is the first, most critical step in cultivating a true thinker. So the powerful thing about this is that this works across every subject. In science, it's inferring the conclusion from data. In history, it's inferring motive from a primary source. Literal and inferential reading is fundamental to problem solving. So Kidlin's law states that if you can write down the problem clearly, you're halfway to solving it. It emphasizes that clarity in problem definition is the most critical step toward effective problem solving. Once students understand the literal and inferential meaning towards a problem, students can start to select strategies to solve it. Also, what we can do is to make thinking and problem solving explicit, and that's modeling it. This is the metacognitive approach. Traditional education is very good at teaching topic knowledge. However, not much attention is spent on explicit training of thinking skills. So don't just assume students will naturally pick up these skills. You must give them instructions. Name the strategies. Tell them that today we're going to use Venn diagrams to compare and contrast two historical figures. Or, let's apply the scientific approach to test the validity of this theory. Once the strategy is named, we can explicitly teach the steps in a structured way on how to utilize these strategies. We can model this out by walking through the strategies step by step. Visual and physical strategies. They can also be helpful. Sometimes drawing out diagrams or acting out problems can be useful when solving complex problems. By visualizing the problem, students externalize abstract ideas into concrete representations, making relationships, constraints, and processes easier to grasp. Diagrams can reveal hidden structures, highlight key variables, and support strategic planning. Acting out problems, especially in word problems or real-world scenarios, engages kinesthetic and spatial reasoning. This helps learners embody the logic and sequence of events. These visual and physical strategies reduce cognitive load and foster deeper understanding, especially when it comes to complex or multi-step problems. Now on to training perseverance. So something I've noticed in a lot of students when they face difficult questions is that they can tend to give up easily. And what they end up doing is guessing the questions randomly in order to finish the task. Instead, what they should really be doing is taking the time and effort to attempt the question. They should be trying different strategies and learning to fail. When a student gives up and starts guessing, it's not a sign of laziness, it's a signal. It's a signal that they've hit a wall and lack the strategic tools and the belief to climb it. Their motivational system has shut down. So how do we build that resilience? It's a blend of culture, strategy, and targeted support. We need to cultivate a culture that values the struggle. We need to make our classrooms psychologically safe for difficulty. Normalize productive failure. We need to explicitly tell our students that if they're feeling stuck, it means their brain is growing, and that's normal. The struggle is where the learning happens. Frame it as a necessary and positive part of the process. Another strategy would be to provide process-oriented hints when students are stuck. Instead of giving an answer, prompt a strategy. So instead of telling them, the formula is a squared plus b squared is c squared, you can try asking them this. What's a strategy we can use when trying to find a missing side of a triangle? Or how could drawing a diagram help you here? So this works because it forces the students to retrieve and apply a general problem-solving strategy from their toolkit. This strengthens the metacognitive skill of planning and resilience. So we all agree that teaching thinking is essential. Now, the big question is, how do we actually do it without throwing our existing curriculums out and starting from scratch? The answer is not a massive overhaul, but a strategic integration. It's about taking the curriculum that you already have and making it thinking intensive. And let me provide you with some ideas and actions that you could use at school. Step 1, start with a curriculum audit and mapping. This is the foundational step. Conduct a review of your existing units and lesson plans. For each unit, ask yourselves two simple but very powerful questions. What is the core thinking skill that students need to be successful here? And secondly, which of the 6 cognitive traits does this most directly fit into? By doing this, you create a cognitive curriculum roadmap. So here are some examples on what this could look like. A science unit on ecosystems might require interpreting information charts and data evaluation. This could be mapped as inferential reading or strategy and method. A history unit that on ancient civilization that teaches students to evaluate plausibility of historical accounts could be mapped to reasonability. An English unit on persuasive writing that teaches essay structure could be assigned to strategy and method. This mapping doesn't change what you teach. What it does is reveal the cognitive requirements within your existing curriculum. Then we have step 2, explicitly stating the thinking objective. Here we make the implicit explicit. In your lesson plans, alongside the content objective, you can include a thinking skills objective. So example here, content objective, students will understand the causes of World War I. The thinking objective, students will practice the strategy of sourcing and corroborating 3 different primary documents to build an evidence-based argument. This will tell the students and the teacher that the thinking process is being assessed and valued just as much as the final answer. Then we go on to step 3, designing thinking-focused questions. When assessing for understanding, you must also probe the how, not just the what. Questions like, here are 2 accounts of the same event, of the assassination of Archduke Ferdinand. One is from a Serbian newspaper, one from an Austrian diplomat. Which do you find more reliable and why? So this question assesses topic knowledge, literal and inferential reading, and also reasonability. Moving on to step 4, the power of meta-reflection. The learning is cemented when students reflect on their own thinking. At the end of a unit or a project, ask the students metacognitive questions. So something like, which aspect was most challenging for you in this unit and why? What strategy did you use that was most effective? How could you use that same strategy in your science class? This process teaches students to self-monitor and transfer the skills, which is the ultimate goal. So now I'm going to move on to how we can utilize AI as a partner in this mission. So I'm sure we all know by now that society is being transformed by technology. Students in our classrooms today will be graduating into a world where AI is embedded in every profession. To prepare them for that future, we can't educate them using only the tools of the past. We have a responsibility to not only teach about AI, but also to integrate AI in education, modeling how a powerful tool can be used ethically and effectively to enhance human intelligence. It's about evolving our practices to meet the demands of the world that our students will inherit. And as we discussed in previous webinars, AI excels at automating routine tasks. This can free us up to focus on the high-impact, human-centric teaching that we just described. Think of AI not as a threat, but as a dedicated teaching assistant. The goal is not to replace teachers, but to amplify their potential. So what does this actually look like in practice? It would be intelligent automation. Think about some of the most time-consuming, labor-intensive aspects of teaching. That would be spending hours grading, analyzing patterns in student errors, and trying to piece together why a student is struggling from countless data points on countless different assignments. And this is where our platform can step in as a partner. We use AI to automate the process of data analysis and recommendation. By using technology, we can process thousands of data points from student interactions in real time. Instead of seeing wrong answers, we are detecting the pattern of wrong answers. So for example, identifying that a student consistently struggles on problems requiring inferential reading, or they may abandon tasks that require sustained perseverance. Then, based on this diagnosis, instead of handling a raw data dump, our platform can provide a recommendation. It can tell the specific cognitive skill that needs strengthening. The exact training modules and resources required to train these are also provided. By automating this process, it frees teachers to focus on the how and also the why. So the benefits of this are we gain time, which is our most precious resource. By handing over the heavy lifting of data crunching and initial analysis to AI, we give teachers back the gift of time, and time that can be reinvested where it matters most. That could be on one-on-one conversations, smaller group instructions, or building stronger relationships, and so on. Secondly, we could achieve unprecedented scale in personalization. A teacher as a single human can only differentiate so far. It is incredibly challenging to track the unique cognitive traits of 30 students simultaneously. By using technology, we can do this effortlessly, allowing an individualized learning pathway for every student at a scale that was previously thought impossible. And thirdly, the third benefit, we move from reactive to proactive teaching. Instead of waiting for a student to fail a major test, AI can give early warning signals. And you can see a dip in perseverance or a pattern of errors in strategy selection as it's happening. This allows intervention before the student experiences significant failure, building their confidence and preventing small gaps from becoming hazards. Now, what I'm going to do is show you our platform and how we are currently diagnosing our students and creating curriculums using our author platform, which is specifically built to operationalize some of the things that we've just discussed. We've been using this over the past 2 semesters at our own campuses and at schools in Hong Kong. I'm just going to quickly share that with you. So yeah, this is the author platform here. What I'm going to show you is first how we structure our curriculums. So here, this section here is how we create the cognitive roadmap for different subjects. So far, we've mapped out a curriculum focusing on reading, mathematics, thinking skills, and also general problem solving. We've used this mapping to classify questions, training modules, and assessments, and we're currently using them in schools in Hong Kong to assess capabilities and also training them and diagnosing their overall levels. So as you see here, we've got different languages. We've got English and Chinese, and we can also add different languages as well. I'll show you some of this stuff. We've got here some of the different subjects. Obviously, we can add new subjects as we go. We can add science, history, geography, whatever. And then you choose the strand. So different types of text types that you're looking at. Here are some of the strategies that are explicitly listed. So we've mapped different types of techniques that can be used when it comes to reading in general text. And, basically you can map it out very in quite a lot of details. So now basically you search up some questions. So what we do is we add questions in. You add questions that you think relate to certain techniques and strategies. I'm going to show you some of our sample questions. You can upload images, reading text. Here in the text, this is probably something related to inferential reading. You can use the same image for multiple questions. So we got quite a lot of questions here with different texts, different analytical techniques. I'll show you some of the stuff we've been doing when it comes to problem solving, some of the 6 behavior methods I was talking about: perseverance, general knowledge, thinking skills, strategy and method, analytical thinking, creative thinking, critical thinking. Different. Again, we've mapped the critical thinking out pretty in quite a lot of detail. We've got a lot of different question types here: strengthening arguments, conditional reasoning. And basically, once you've added in your questions, we can then go on and create training modules. So here is where you put the questions that you've mapped out and questions that you've added in, and we can create a training module here. So for example, ABC. Let's pick language. We're going to do it in English. Let's do problem solving, thinking skills. We want to focus on critical thinking, proposition and conclusion. Select the grade. How many questions? How many sections of training? So you can do multiple sections that, kind of ramp up in difficulty. You can include an assessment here and also add a training booklet. So students can then log in and see the training booklet. They can see the PDF version, or they can download it and print it themselves, or you can print them for them as well. Then you add the questions in, and basically what you see when you create them, you get something like here. We've got quite a lot of training modules in Chinese, English, and if you look at here, we've mapped out questions and we've added them into the training modules. And what we then do is assign these to students. Here, I'm going to show you what we do when it comes to creating tests. So it's a similar process. Choose a language, choose the test name, what kind of test you want. Do you want it to be adaptive or non-adaptive? I mentioned that earlier. So adaptive means the questions will adapt to the student's ability. So if they're kind of struggling with certain questions, the questions will get easier. If they're doing really well, the questions will get harder. You can choose adaptive or non-adaptive. Purpose, what you're doing it for. Subject, same as before, total amount of questions and whatnot. And then you can create the tests. And then here you can maintain the different tests. So we got quite a few different assessments here that we've been using. And here now I'm going to show you what it looks like from a student perspective. Once these modules are assigned. So here's a student. You assign the assessments to them. So when they go in, they'll see the different assessments. So, here they've done.
Just to interrupt, Jeff, we're still looking at the same screen there. It's the test list.
Okay. Yeah, give me one sec. Yeah, so here's the student platform. So they'll see assessments, training modules. Here we go. They did different assessments here: thinking skills, strategy and method. Basically, we're assessing their overall ability level. Then what we do, based on their ability level, we assign training modules that are adapted to their overall ability. I'm going to show you a diagnostic report. So here's a sample one. So the student, here we go. We got this the chart, the reading speed, thinking skills, method and strategy. So he's quite good at reading. Struggles, he's okay with some of the other stuff. Seems to struggle with perseverance and speed and accuracy. So we'll look at down here some of the stuff we've been assessing him on. So look at the data here. We've got reading speed and analysis. We've got charts here. So these dots, these are different students within the cohort. So we compare them with students within their own classrooms. We can also compare students within regions, within schools. We can change the data metrics on this. So if you can see the student, he is kind of below average when it comes to literal analysis, but when it comes to inferential analysis, he's very strong. He's got good performance, but he kind of struggles when it comes to speed. So we got here, this is kind of explains in detail what we're kind of looking at here. And here, thinking skills, critical thinking is around average. Logical thinking is a bit below average. Overall, bit below average. Here we're choosing different strategies that he's good at or not good at. Counting techniques, acting it out.
Just to interrupt, Jeff, just still looking at the same screen which says training modules.
Okay. Sorry about that. Here we go. Here's the spider chart that I was talking about with all the different analysis that we're doing. So look at this diagram here. His overall level, his literal analysis, his inferential analysis. The red dot is him. The other smaller dots are, his classmates. And yeah, like I said, the more people that do this, the more you can compare. You can compare it regionally. You can compare it within school. So he's quite good at inferential analysis, performance-wise. It takes his time. Here we analyze his critical thinking compared to his cohort, his logical thinking, overall ability, method and strategy. So we kind of assessed his counting techniques, acting it out, methods, and overall ability here, general knowledge, speed and accuracy, and perseverance. So you can see here is actually quite low in perseverance. So what that means is in one of the modules, so we have a diagnostic module, and what that does is it gives students multiple attempts at questions. So if they get it wrong, what happens is we give them a hint and we see if they will attempt it again. So they can do an attempted question 2 more times, gives them another hint, and we'll see how many attempts they'll do. If they don't want to attempt it, they can actually just skip it. So this basically shows us that this child probably just skipped all the questions when it comes to the diagnostics. So he basically didn't attempt multiple times. So we can know that this student has a gap in perseverance. So we can target next time he's doing training. We'll tell him, hey, you should try multiple times. You can come with some interventions on how to help him improve that. So yeah, that's more or less it for today on what I wanted to show you guys. So happy to answer any of your questions.
Great, thank you, Jeff. That was a really really interesting session. I'd like to just ask a quick question myself. So in terms of how schools would implement a training like this, what does that look like practically, and what is the best practice model that you might suggest for an international schools to successfully integrate this into their already quite tight timetables?
So basically what we're doing now is we've got a train the trainer model. So what I know is a lot of international schools have interest in, doing metacognition, doing all this thinking skills training, but there's not a lot of expertise in these schools. And so what we do is, we'll provide a training course to some of the teachers on Zoom, obviously. And basically we'll make these teachers kind of specialists within their own schools when it comes to metacognitive training. So they'll learn how to train the stuff, how to use our platform. And what they'll do is then they can be the subject matter expert within their own school, and then they can run this in classrooms. And basically, these assessments and these training modules can be done at their own time. So you might say, 1 hour a week we're going to spend doing some of these training modules, doing some of these assessments. There will be training material provided for the students as well. So basically what we do is we give access for a semester, we train the teacher, and then the teachers can then, during that semester, how they want to do it, at what speed. You could do it in like a couple of weeks if you want, or you could take your time with it. And students can also log in at home. They can log in at home and train some of it themselves. That's self-directed learning. Parents can also look at their progress. So there's a lot of progress checking as well. They can see the diagnostic report. A lot of good information there.
Great, thanks, Jeff. And would you mind sharing just a few insights into the pilots that you've done and some of the success stories that you've had, and how long were students on the training programs for before they were starting to see that, incremental improvement?
So basically, we started this project last year around September, and we've had 2 pilot schools in Hong Kong. And what we did is we diagnosed we started off with initial assessments for about 120 students in Hong Kong and 30 students in Australia. And then we compared the data. So Australian students tended to start off a lot better. That's because Australian curriculum, they kind of integrate some of these skills already. They've also got new initiatives to kind of do this as well. Hong Kong is a little bit slower in this element, but obviously the government is addressing this as well. And what we noticed, and then what we did like a 10-week training course with the students in Hong Kong. And what we noticed, the students do catch up. Obviously, they're still a little bit behind compared to Australia, but their growth rate compared to Australia was quite high. And what that shows you is that, this stuff can be taught. It's not an innate ability. It's about, having the knowledge on how to train it, the concepts and, the tools available to train this. And what we saw is a lot of improvement in terms of perseverance. We've got data as well. We have a lot of data that we share with principals, parents and whatnot. The principals were very happy with what we're doing, and they've continued as clients, and we're still running these programs with them this semester as well.
Great.
And obviously
Thanks.
now
Thanks, Jeff. And so there's quite a few schools on the call today, from quite a range of different countries. And I was just curious as to know, what sort of pilot program or free trial could you offer for schools that might be interested in kind of dipping their toes into something like this?
Thanks for that. So yeah, I know that we want to offer kind of like a low risk kind of way for schools to try it out. And what we're offering is like a demo diagnostic assessment. So schools can pick, a cohort of students, maybe like 10 to 20 students within a cohort. Say like if they want to try it with P5 students, they can pick 10 students. We'll give them demo logins. We'll kind of onboard the teachers on how to use the assessments. It's actually pretty easy. We'll provide the logins, and they can test these demos out with 10 students, and get an overall feel of the platform, the type of questions, and the kind of data that they could get.
Great, thank you very much, Jeff. So if there are any schools on the session today that are interested in exploring a free demo or free pilot, I will be following up with the recording from today's session, along with Jeff's slides. So please do get in touch. You can get in touch with Geoffrey if you wouldn't mind putting your email in the chat. I will actually include Jeff's email in the email that I'll follow up to all the attendees today, but just so you have it firsthand as well. Fantastic. Well, yes. If there are no questions, we'll give it 10 seconds. If there's any burning questions from any of the attendees today, please add them into the chat. If any of you do have any questions at all, if you go away from today's session with a few thoughts, please do get in touch with us. I will be sending a follow-up email in the next couple of hours. So please do check your inboxes. And thank you so much for your time today. Really appreciate it. And thank you very much, Jeff, for that really interesting session as well.
Thanks for organizing, and really appreciate everyone joining, and hope you learned something.
Great. Thank you, everyone. And have a pleasant afternoon and great evening. Thank you.